Welcome back, folks. Here we go with section 10.7, trigonometric equations and inequalities. Folks, this the part one of this video, it's going to take a long time. I've got a set of 12 example problems I want to show you. There is no handout for these because these are straightforward equations. They all have the same instructions. I'll show you those instructions in a minute. So it's really just a matter of you writing down each equation, kind of going through the solution with me as I do them for you in the video. But first, I have a couple things I want to get started with. These are kind of simple questions to get us started. And the reason I'm showing you these is because it's going to prevent some mistakes in the future and also help us learn a new problem-solving tool. First one here says simplify the algebraic expression 2 pi k plus pi. Well, let me tell you what it does not equal. 2 pi k plus pi does not equal 3 pi k. I'm not sure why, but students want to do that all the time. That is totally false. So if that's not what this expression equals, let's see what it does equal. 2 pi k plus pi. Remember, k represents any integer. It could be -1, +1, 0, 15, -28, etc. Any integer. So if we were trying to simplify this, really we can't. It's already simplified. There's no like terms we can combine here. 2 pi k and pi are not like terms. Yes, they both have a pi in it. So if we really wanted to, we could factor out a pi and write it as 2k plus 1, pi times quantity 2k plus 1, but that's it. You cannot combine those two terms to be 3 pi plus k. Okay, question 2 here. And again, this is an intro question. If u equals 2x and u equals 5 pi over 6 plus 2 pi k, what does x equal? Well, we're going to use a technique here in a little bit called u substitution, where we use the variable u to represent something more complex that'll help us solve some more complicated trig equations. So if u equals 2x and u equals 5 pi over 6 plus 2 pi k, I can take those two things and set them equal. So I'm going to have 2x equals 5 pi over 6 plus 2 pi k. Now if I'm solving for x, which is what I was asked to do here, I'm just going to divide both sides of this equation by 2, and I'm going to be left with x equals, let's see, 5 pi over 6 divided by 2 is 5 pi over 12, and when I add 2 pi over k divided by 2, that's just plus pi k. Okay, so that's what x equals. I'm really done with the problem. I do want to show you a slightly different format though. So this is one final answer, and let's take a look at another. So I have x equals 5 pi over 12 plus pi k. Well, what if I wanted to combine these two numbers? If I want to combine them, then I need to write pi k as a fraction with a 12 in the denominator. So I'd need to write this as times 12 over 12. So that's my this is my multiplier equal to 1, so that I'm not actually changing the value. And then this would be 5 pi plus 12 pi k all over 12. So the two expressions that I have boxed there are equivalent. And I'm writing them these two different ways because you'll see as we get into some more of these equations we need to solve in this section that sometimes this form right here is more convenient to show specific solutions on the interval from 0 to 2 pi. Okay, folks, so let's get into it. As I mentioned, I have 12 example equations we're going to solve here, and every single one of these has the same set of instructions. Find all the exact solutions to the following equation. That's step 1. Then list the solutions that are on the interval from 0 to 2 pi. So we're going to go ahead and get started right away. So the first thing I'm going to do to solve this equation is I'm actually going to make a simpler equation. I'm going to try and solve this one. Cosine of u equals √3 over 2. That looks a whole lot easier than cosine of 3x. equals root 3 over 2. And if I make that my new equation, then I have to say that I've let u equal 3x. And we're going to use that at the tail end to actually find out what values of x what values of x are solutions to this equation. Okay, so now that we have this new simpler equation, I think I can say that u equals, well, any angle that gives me a cosine ratio of root 3 over 2. So that would be pi over 6 plus 2 pi k. There's another angle. I could also have 11 pi over 6 plus 2 pi k. Those are two angles, two sets of angles that have a cosine ratio of root 3 over 2. Well, that's great, but I wasn't asked to solve for u. I was asked to solve for x. So now I'm going to go back and substitute 3x back in for u. So it's going to look like this. 3x equals pi over 6 plus 2 pi k, or 3x equals 11 pi over 6 plus 2 pi k. Next step to solving each of these equations is I'm going to divide both sides by 3. Do it over to both equations, and then I'm left with the following. X equals, let's see, pi over 6 divided by 3 becomes pi over 18. And then I have plus 2 pi k over 3. And that's one set of solutions to this equation. Over here I have x equals 11 pi over 18 plus 2 pi k over 3. So right here, find all the exact solutions of the following equation. Those are my exact solutions. Okay, that remember, k represents any integer, so this is going to give us any iteration around the unit circle where we have cosine of 3x equals root 3 over 2. But I'm not quite done, because I'm now asked to list all the solutions which are on the interval from 0 to 2 pi, and that's a little bit trickier step. So what I'm going to do is I'm going to take each of these solutions and rewrite them as a single fraction. So that just kind of makes the next step easier. So this one is going to become x equals pi over 18 plus 2 pi k over 3, and I need to multiply that by 6 over 6 to give me a common denominator of 18. So now I'm going to have x equals pi plus 2 pi k times 6, which is 12 pi k, all over 18. So this expression right here and the one that's boxed right above it, they're equivalent. It's just one. This one's written as two separate fractions. This one's written as a single fraction. I can do the same thing over here with our second solution. 11 pi over 18 plus 2 pi k over 3 times 6 over 6. That'll give me my common denominator of 18. And then I have final answer here of 11 pi plus 12 pi k all over 18. And again, that boxed answer is equivalent to the one above it. So again, why am I doing this? Because let's scroll back up here. I'm trying to find all of the solutions that lie on the interval from 0 to 2 pi. So what I'm going to do now is I'm going to start listing them. Okay, I'm going to actually make kind of a table here to start listing them, and I'm going to, just to keep things straight in my table, I'm going to call this x sub 1 and x sub 2. And I'm going to start by listing some k values, and then listing some x1 values and some x2 values. And we're going to stop when we get when we get up to 2 pi. So I'm just going to go ahead and list some k values here. Notice that I decided to start with 0. If I picked k equals -1 for either of these two x values, I'll get an x that is less than 0 and we were told that we have to be greater than 0, so I'm not going to do that. So if x equals 0, I have a solution here of pi over 18, and this one would be 11 pi over 18. So those are the first two solutions I have on that interval from 0 to 2 pi. Now if I let k equal 1, I'm going to have pi plus 12 pi. So that's 13 pi over 18. And my x2, if I let k equal 1, I'm going to have 11 pi plus 12 pi. Let's see, that's 23 pi. 23 pi over 18. Okay, so 4 solutions so far on that interval from 0 to less than 2 pi. All right, so now let me let k equal 2. I'm going to have, this will be 24 pi plus another pi. That's 25 pi over 18. And down here, if I let k equal 2, I'm going to have 24 plus 11. That gives me 35 pi over 18. So far I have 6 solutions that are on that interval from 0 to less than 2 pi. All right, let me go ahead and try 3 here. So I'm going to substitute in k equals 3. That's going to give me 36 pi here plus another pi. That's 37 pi over 18. And I'm going to argue that this answer doesn't count and that we can stop with just these 6 values. Why on earth am I stopping here at a seemingly random point? Well, remember what we were asked to do. We were asked to find the solutions on the interval from 0 to 2 pi. So that's another way to think of that is from 0 to less than 36 pi over 18, because 36 pi over 18 is the same as 2 pi. So once I got to 35 pi over 18, that was my last answer. All right, folks, we're going to move on now and do the next example problem. I warned you, these do take some time, so you're going to have to bear with the length of the videos. Next problem here, tan of 6x equals 1. Same instructions as the previous problem, so let's go ahead and get started. This looks scary. This doesn't look scary. So we're going to let u equal 6x. So if the tangent of u equals 1, I know that means u equals pi over 4 or 5 pi over 4 on the unit circle. Now, there's something about these two angles that I hope you remember. They are exactly pi radians apart. So I can say u equals pi over 4 plus pi k. So this is not a plus 2 pi k problem. We can consolidate it to a plus pi k problem. Well, if u equals pi over 4 plus pi k and u equals 6x, I can go back and substitute in for x and say 6x equals pi over 4 plus pi k. Dividing both sides by 6 will give me pi over 24 plus pi k over 6. And that's my answer. Okay, folks, that right there is the all the exact solutions to the equation tan of 6x equals 1. If interested, we could write this in a slightly consolidated form. I can add those two fractions together. So that's going to give me the following answer. X equals pi over 24 plus pi k over 6. Now if I want both of these to have a denominator of 24, I can multiply this by 4 over 4. So now I'm going to have pi plus 4 pi k all over 24. And those two boxed solutions are equivalent. Okay, folks, this one, I'm going to be honest with you. This question, this is tedious because we're done with this first part, the exact solutions. We're done with that. Now we still have to list all the solutions on this interval, and this is extremely tedious, this one. You will not have to do many like this. But I'm going to use the same procedure that I did in the last problem. I'm going to start with kind of a tabular format here. I'm going to list some k values, and I'm going to list some x values, and we'll see where this takes us. Wow, did you get all that, folks? Take a look at that kind of separated list. And again, I believe WebAssign will ask you to do a couple of these ridiculous ones with a whole bunch of answers, but wait. This last one, folks, is wrong. 24 times 2 is 48. So we have to be smaller than 48 pi over 24. That's why I'm Xing out that last one. Folks, this video is getting ridiculously long, so I'm going to go ahead and shut it down here and look forward to the rest of section 10.7 in more videos.